In this video for section 10.2, we're going to be looking at situations where we're comparing two population means and testing a hypothesis about them. So in some situations, we might want to decide between two products, evaluate two different proposals, or decide between two applicants. And so that's when we might want to apply this process. In this section, section 10.2, we are looking at situations where the samples are independent. They're two separate samples, and the occurrence of a value in one has no influence on the occurrence of a value in the other sample. So two separate samples here. So the process for this is pretty similar to the process from chapter 9. First, we're going to write our hypotheses. Remember that the null hypothesis always contains the equality sign, so it might be equals, greater than or equal to, or less than or equal to. And then we usually rearrange this so that mu1 and mu2, because now we have two means in our hypothesis, will be on the same side of the equals or inequality symbol. And you'll see this when you do the homework. These hypotheses are going to be multiple choice, and you'll see that they are written this way. The second step, and this is different from chapter 9, is that we are going to identify whether we can assume that the variances are equal or not. And we can do this by looking at the standard deviation, because remember that the standard deviation squared gives us the variance. So if the standard deviations from the samples are pretty close to being the same, then we can assume equal variances. And there's a box that we need to check in Minitab if we are assuming equal variances. So we will get different values depending on whether or not that box is checked. Sometimes the problem will tell you directly whether or not you should be assuming equal variances. Other times it's up to you to decide based on the values that they're giving you for standard deviation. We are going to use Minitab to calculate our p-value. Also, sometimes we will get a test statistic that we will have to put into our homework questions. We're going to be using 2 sample t in this section. And then we are going to compare the p-value to alpha. So remember, if the p-value is less than the alpha that's given to us in the problem, we reject the null hypothesis. If the p-value is not less than alpha, then we do not reject the null hypothesis. Or sometimes this is written as fail to reject the null hypothesis. And then from there we can make our conclusion. So let's look at example 10.5. It says, suppose an independent agency wishes to conduct a test to determine whether name brand ink cartridges generate more color pages on average than competing generic ink cartridges. A simple random sample of 10 users was selected to test the name brand cartridge. They found that the cartridges printed a mean of 322.5 pages with a standard deviation of 48.3 pages. A sample of 8 users tested the generic cartridge, finding a mean of 298.3 pages with a standard deviation of 53.3 pages. Conduct the test using alpha equals 0.05. So, first we're going to write our hypotheses, and to do that we're going to look at the claim that is given to us in the question, or what they're testing. What they want to know is whether the name brand cartridge generates more color pages, and that more is the key idea here, because what that's telling us is that if I set the name brand to be mu1, it's important that you keep track of which is which when you're doing these problems, and I'm going to set the generic to be mu2, then what I'm claiming is that mu1 is greater than mu2, right? Because I'm claiming that the name brand is generating more pages than the generic. So to rewrite this in terms of getting the two mu's on the same side, I'm going to subtract mu2 from both sides, and that gives me mu1 minus mu2 greater than 0. And so this is my alternative hypothesis. And then remember, my null hypothesis is always the opposite of that. So I'm going to write this over here. The null hypothesis is always on top, but I always write the alternative hypothesis first. So mu1 minus mu2 is greater than 0. For my alternative, that means my null hypothesis is that mu1 minus mu2 is less than or equal to 0. It's always the opposite of the alternative. So those are my hypotheses. Okay, so now in order to test these hypotheses, I'm going to go to Minitab, and I'm going to go to Stat, Basic Statistics, and down to 2 sample T, which is below 1 sample T and 1 sample Z that we used in Chapter 9. Now, in one of the homework questions, you're going to use each sample as in its own column. I would use that if I had raw data. Here I have summarized data, so I'm going to use summarized data. I'm going to enter my sample size, sample mean, and standard deviation, which were given to me in the problem here. So for sample 1, which was the name brand, the sample size was 10. Sample mean was 322.5, and the standard deviation was 48.3. And for sample 2, the sample size was 8. Sample mean, 298.3, and standard deviation, 53.3. Then I'm going to click on Options. And then remember, when we're doing hypothesis tests, we don't have to worry about the confidence level. I want my alternative hypothesis to match the alternative hypothesis that I wrote, which was that mu1 minus mu2 is greater than 0. So the difference is greater than the hypothesized difference. If I look up here, the way that they're always calculating this is sample 1 minus sample 2. So you want to make sure that you're getting it in that order in terms of matching up which one you're putting in which. And then, do I assume equal variances? Well, looking at my standard deviations, I'm comparing 48.3 to 53.3. Those are pretty close together in the grand scheme of things, so I'm going to check the Assume Equal Variances box. The hypothesized difference is 0, because in this case, what I'm looking at here is 0. If it were a different number, then I could put a different number in that box. And that would happen if, for example, your question was saying, was the difference more than 10 pages? Then I would have the number 10 here, and that would be my hypothesized difference. But in this case, I'm just asking if it's more, so my hypothesized difference would be 0. Click OK. And here, for some reason, what we want is usually towards the bottom, so here is what I'm looking for. The t-value is sometimes going to be something that you're going to put into MyLab. 1.01 would be the t-value in this case. P-value is what I'm looking for to answer my question. So p-value is 0.164. Remember, if I need more digits, I can select it, click on the arrow, and change the number of decimal places. But 0.164 is enough for me to answer this question. We are trying to use an alpha value here of 0.05. So to test the hypothesis, is the p-value less than alpha? No, the p-value is not less than alpha. 0.164 is not less than 0.05. So, since the p-value is not less than alpha, we cannot reject the null hypothesis. Or we fail to reject the null hypothesis. And what this means in terms of our question is that we do not have evidence that the name brand cartridge generates more pages. So we do not, or we don't have sufficient evidence that the name brand generates more pages. So that's my conclusion.